Hey there, everybody. I am going to try to get through a lesson today on solving algebraic equations, which was a request from my 6th grade class. That's what they're learning right now, also called one-step equations. And I am sick, so I will do my best to get through this without sounding too crazy. So anyways, here we go. So again, it's called solving algebraic equations, also known as one-step equations. And something that's really important about these is there's a check piece that you can do. As long as you understand how to use it, there's a check piece that you can do, and it'll catch your mistakes. So if you are careful and understand how to use that check piece, it should always help you to determine if you're doing things correctly or not. Okay, so most important thing to know about solving a one-step equation is that the goal is to get the variable by itself. Okay, and when we actually go through and work through some problems, that'll make more sense. But a variable, in case you're not sure or can't remember, is just a letter. Okay, so it's a letter used in algebra. It's typically X, Y, or Z, but sometimes they throw in A, B, M, Z, I said Z already, F, K. It can be pretty much any letter. So, but what you're trying to do in a one-step equation is trying to determine what value makes an equation true when you have a missing piece, basically. So it's kind of like a puzzle. All right, so answers for these are going to look like this. Variable equals constant, or constant equals variable. And again, I think I said it before, but shout out to my 6th graders. They're learning this algebra right now, and they haven't dealt with negative numbers yet. We haven't gotten into integers yet. So this video is going to be based 100% to just positive numbers. So I will make another one at a later time that includes negative numbers. But for right now, because I'm aiming this at them specifically, I don't want to confuse them. So right now we're going to have answers that are variable equals constant. And again, constant, if you're not sure what a constant is, this is just a number by itself. And for this video, that is going to be a counting number. Okay, so positive whole number. So you can have an answer that is the letter is equal to the number, or the number is equal to the letter. What else you need to know about these? You should always check, okay? So the check piece, the check piece that you can use is important, okay? Important. Sorry. Again, I'm not feeling too great. So bear with me. All right, so the check piece is really important, and it will actually tell you if your answer is correct or not. So I will walk you through how to do a check piece, and I require them for all of my solving equations in algebra and my pre-algebra classes, and it's for good reason, because as you get into more complicated equations, it will actually save you, and you'll know that you got problems right if you use the check piece correctly. Okay, let's go ahead and try some problems. And if you're in my 6th grade class, I'm going to use some of the examples we used in class on the homework, and I'm going to throw in some new ones. So here we go. Okay, let's go ahead and start with a pretty basic question. Okay, first equation. So the first thing you need to realize about this equation is that this x value right here, there is only one number that will fit into this x value that will make this statement true. Okay, so when we're solving these types of equations, we need to determine what value makes the equation true. And there is only one value. Okay, so this equation is asking me what number can I add to 6 and I'll get 20. Okay, so the answer, hopefully everyone understands, and hopefully everyone can do that in their head. The answer should be 14. So x should be 14. But what we need to do is we need to figure out how to show our work in order to improve and grow on our algebra equation solving later on. Okay, so as I tell my classes when I first introduce this, this is the easy step. This is the beginning. It's easy. You should be able to do it mentally, but you have to show your work because it is going to get more challenging. And as my 8th graders could tell you, some of them are minimalists, which means that they try to get away with doing the minimum amount of work they can do, trying to do some of this mentally, and it's caught up to them now because some of them are having a lot of troubles as we've gotten into more complicated algebra with larger equations and variables on each side and just more complicated stuff like that. So it's really important that you know how to show your work. Okay, so for this problem, I'm going to actually write out exactly what this question is asking me, okay? And I'm going to put it in quotes. So what number, okay, that's going to be my x, okay? So what number can I add to 6 that will make 20? Okay, and there's so many different ways you could say that, but that's the way that we're going to read this, okay? So what number can I add to 6 that's going to make 20? And again, we already said it should be 14, right? So x should be 14. That's our mental check. But again, we need to show our work. So let me show you how to show your work on something like this and do the check. So I'm going to rewrite the problem. Excuse me. Okay. So what we need to do is we need to take this 6 and we need to move it over here to join this 20, okay? And you can't just add it over there. That doesn't work because you're moving across an equal sign. So in order to show your work and solve this problem, we need to undo this 6 and move it to the opposite side, okay? So we are going to undo this operation. So we need to do the opposite operation. Okay, and we are moving the 6 because we need to get this variable by itself. Like on the last, at the beginning when I said you need to get the x on one side and the constants on the other side. Okay, so we're going to do the opposite operation. So since 6 is being added to x, we need to subtract it. And if we're going to subtract it on this side, we need to subtract it on this side. Okay, then I put basically I put a line here that's kind of like my equal sign for my equation just to kind of make it more organized, okay? And what you're essentially doing again is you're taking this 6 and you're moving it to the other side of the equal sign. But when we move it over here, it changes its sign. You can't just move it over. When it moves across the equal sign, it changes. So if I have 6 and I subtract 6, these cancel. So you just put a line through those. This x comes down, this equal sign comes down, and then you need to solve this piece, okay? Really important. This piece gets solved. It would be great if my pen worked. Here we go, let's see. There we go, okay, solve. Okay, so you can do this part in your head, 20 minus 6, 14, which we already knew up here, x should be 14. Circle your answer. We won't do all of these arrows each time. I just want to do that for the first time so you can kind of follow the path of what we're doing. Okay, so now the check piece. Okay, to check your work, you write the original problem. Okay, and then we're going to substitute. for your variable. And for this variable, it should be x. So in place of x, we're going to put 14 because up here we said x is equal to 14. So we're going to actually check to make sure that that is a true statement. Okay, then we are going to solve the operation. And the operation for this is a plus. So we're going to solve this in our head. So we're going to actually go through and we're going to say 14 plus 6 is equal to 20. Okay, and then I'm going to bring down my equal sign and bring down my 20 because these need to match. So I check it off because they do match. Okay, this is all the check pieces. So the check piece is going to be different looking for every single problem. You don't want it to equal 14. You want to prove that 14 makes this equation work and it balances it out. If you, for some reason, messed up on your subtraction here and you said, well, 20 minus 6 is 13. When you come down here, if you substitute 13 here, you would get 13 plus 6. And if you know your math, that's only 19. And if you said 19 is equal to 20, that's not true. So if it's not true, that's where you can go back and you can say, oh, something's wrong. I need to look at my problem again. Okay, let's try some without doing all of the arrows, and we'll align the checks with our problem so all of our work is organized. Okay, here we go. Okay, the next problem, x minus 10 equals 12. Okay, so this is asking me what number can I subtract 10 and get 12. Okay, so again, like the last problem, we need to do the opposite operation to move this 10 over here. It's being subtracted from x, so we need to add it. And we're adding it on both sides of the equation. A subtract 10 and a plus 10, which is technically a negative 10 and a positive 10, these cancel. Bring down my x, and x is equal to 12 plus 10, which is 22. Okay, then I'm going to do my check. For my check, I write the original problem. I'm going to substitute 22 in place of x. I'm going to do this operation in my head, or I can do it off to the side. I should do it off to the side where you can see it. I'll do it right here. Okay, 2 minus 0 is 2. 2 minus 1 is 1. So I have 12. So 12 is equal to 12, which checks. That is true. Okay, next problem. 2 plus x equals 16. This is asking me 2 plus what number equals 16. This is just like our last one of 14, but it looks a little bit different in the order. So for, again, this one, we're trying to get x by itself. So we need to move this 2 that's attached to it to this side. So 2 is positive. Oh, on these type, it brings up a good point. On these type, we read math from left to right. So this plus sign goes with this x, okay? This 2 is positive because it doesn't have a sign out in front of it. So since it's positive 2, we're going to subtract it to move it. Okay, these cancel. Bring down your x, and I have 16 minus 2, which is 14. And this plus right here just means that x is positive, so you don't need to worry about that. Okay, then we'll do our check. So I have original problem, substitute. I'm working too fast here, sorry about that. Okay, substitute 14 in here, and then actually do this piece. 16 is equal to 16, and that checks. Okay, let's try another one. Let's do, trying to find some that are not negative. That one's negative 2. Okay, let's try this one. X plus 14 equals 10. Okay, so 14 is attached to the x. We need to move it to the opposite side by doing the, oh, this one's not going to work for you. I'll go through this one, but 6th graders, this is to come, sorry. 14, we do the opposite, and x is equal to 10 minus 14, which is an integer, which is going to be negative 4. Okay, so this one is not for 6th grade yet. Sorry about that. That wasn't a good one for me to choose. because I haven't actually taught that to you yet. But you can check it and it will work, but I don't want to confuse you. So let's move on to another one. Okay, let's do x. Let me get a new piece of paper, hold on. So let's do okay, thank you for bearing with me. Again, I don't feel very great today, but I know this is important because I had a request specifically from Miss Ava asking if I would do this. So I wanted to make sure and get it out for her today. Okay, so if I have x minus 60 equals 20, I add 60 to each side. I don't know why I put that there. That doesn't need to be there. Okay, add 60 to each side. That's what I meant to do. Okay, so these cancel. I have x is equal to 20 plus 60, which is 80. Okay, and 20, 60. I can add them over here on the side for you. All right, and then my check piece, original problem. Baron says hello. Substitute. Okay, and actually do this check, which is 80 minus 60. 8 minus 6 is 2. That's 20 equals 20. Okay, so that checks. All right, let's do another one. Let's do x plus 17 equals 19. Okay, again, this is attached to the x, so I need to move it. So I'm going to subtract 17 from each side. X is equal to 19 minus 17, which is 2. All right, and my check on that, again, write the original problem, substitute, and then I actually need to solve this, which is 17 plus 2, which is 19, is equal to 19, which is a true statement. Let's do one more, and then I'm going to do some of the more complicated ones. Let's look at this one. 4 plus x equals 30. Again, this is a positive 4. I'm going to subtract it to the other side. So I have x is equal to 26. And my check for this, original problem, substitute, plus, I'm getting ahead of myself again, 26 equals 30. If I add 4 plus 26, that is 30 equals 30. Okay? All right, now let's try some of the more complicated ones. So all of the ones I just went through are new to you if you're 6th grade. I'm going to go through the homework that we went through together and they did corrections on. So I think I will go ahead and make this a long video. So if you want to keep watching, I'm going to do some of the fraction clearing when you have to clear with multiplication. So it's problems from page 12 if you're in my 6th grade class. So I'm going to go ahead and go through those fairly quickly, decimal and fraction questions. And you're welcome to hang on if you would like to see how those look too. Okay, I do not teach these the way I learned them, and most parents probably learn them because it's helpful to understand proportions, and proportions seem to stick better in kids' minds than when you talk about reciprocals and multiplying by reciprocals. It gets very confusing when you're dealing with middle schoolers especially. So let's go through and I'll show you how I solve these. Okay, so here's one of the problems. So if I have 1/4 x times 5, reciprocal would be to multiply both sides by 4 and you can get the answer. The way that I teach it in class now is to set it up as a proportion and then you cross multiply to solve it. So let me show you what that looks like. So it's also good for the students to realize that the variable, if the variable is sitting off here to the side by itself, it actually belongs in the numerator, and it's a good way for them to remember that by doing it this method. Okay, so first step that we're going to do is we're going to move this variable like I was just saying, up into the numerator. So we have 1x over 4. And then we're going to have this side set up as a fraction. Okay, so any whole number needs to be placed over 1 if we're setting it up as a fraction. So this is what we set it up as. This is called a proportion. Okay, proportion. And that just means that I have two fractions that are equal to each other. I need to figure out what this x is here. And the number 1 here in front of x means the same thing as, so 1x means x, right? So the 1 isn't necessary. But since we're just learning how to do these, the 1 is fine to keep. All right, and then we just go through and we multiply by cross multiplying. So we're going to multiply these two diagonally, and these two diagonally. And we're going to set them equal to each other. So this equal sign comes down. I like to multiply the variable and always put it on the left. It's not necessary though. You can multiply those and put them on the right and these on the left. Again, I like to put the variable on the left. So I'm going to do the variable diagonal cross multiplication first, which is 1x times 1, which is just 1x or x. And then I'm going to do my constants on the right. So 4 times 5, which is 20. And 1x is the same thing as x equals 20. Okay? And the checks are the same thing on these. Okay? If I'm going to check it, I write the original problem. Okay? And then I am going to actually rewrite it as the proportion. Rewrite it correctly, Mrs. Cosgrove, as the proportion. Okay? And then I'm going to substitute. So I have 20 divided by 4 equals 5, or 5 over 1. You can write it either way. It really makes no difference. 20 divided by 4 is 5. Okay? All right. I'm going to get a new sheet of paper because that took a lot of space. I'm going to try not to use so much space on the next one. Okay. Next problem was r over 6 equals 11. Okay, so again, we rewrite this as a proportion. 11's a whole number, we put it over 1, and then we just cross multiply. Okay, and this is just like the addition subtraction ones that we did previous. This is asking me what number can I divide by 6 and I get 11. Okay, so r times 1 is just r, or 1r. 6 times 11 is 66. I'm going to do that here off to the side so you can see it. Okay, and then my check piece. I'm going to rewrite my proportion that I set up. Okay, actually it's the original problem. I'm going to substitute 66 in place of r, and then I'm going to actually solve this, and I should get 11. So 66 divided by 11, 66 divided by 6, I'm trying to go too fast. 6 goes into 6 once with 0, so we do it again. 6 goes into 6 once. The 6 comes down, that's 6. Nothing left, so that's 11. So 11 is equal to 11. That is true. Okay, next one. 7k is equal to 4/7. Okay, then this one, again, we're doing as a proportion, so let's rewrite it as 7k over 1 equals 4/7. And we're going to cross multiply in order to get our answer. And this one is going to give us an interesting one. So we have 49k, because 7 times 7 is 49, and there's the k there, is equal to 4. And then I divide both sides by 49, because I need to get k by itself. So I have k is equal to, you cannot see that, sorry about that. There we go. Sorry, I'm booking along through the problem and you can't even see it. So I'm crossing off the 49s, and this is my answer. So k, I'll write it over here, k is equal to 4/49. And that's one that we talked about was not a very pretty problem, but they're not always pretty. So we need to just be careful with them. Okay, you can also do these with decimals. So I have 11.2 equals x minus 1.8. This one's set up backwards of the ones we've done already, but that's okay. You got the variable equation, variable piece of the equation on the right instead of on the left, but again, it still works. So this minus 108 needs to move because it's attached to the x, so I need to add 1.8 to each side. I'm adding it. This side cancels. I just bring down my x. And then I need to actually solve this. Okay, so I have 8 plus 2 is 0. Bring down my decimal. Carry my 1. So 8 plus 2 equals 10. 0 goes here. Carry the 1. I have 1, 2, 3. And then there's a 1. Okay, so my answer is 13.0, which is just 13. And then I'm going to check that. So if I have 11.2 equals x minus 1.8 as my original problem, if I substitute 13.0 or 13 means the exact same thing in place of x here, and I usually do my substitutions with parentheses so they stand out. And then I need to actually check and see if 13 minus 1.8 is equal to 11.2 for sure. So I'm going to do my work right here to see if I can actually get that answer. I can't take 8 from 0, so I need to borrow. Make sure you borrow correctly. This becomes a 10, and this 3 becomes a 2. Technically, you're taking this from 13 down to 12. Okay, 10 minus 8 is 2. 2 minus 1 is 1, and bring down the 1. Make sure you bring down the decimal. When we're doing subtraction of decimals, remember you have to line the decimals up. It's very important. Same with addition. Have to line them up. But we got the answer we wanted. So we have 11.2 comes down here with the equal sign, and this piece right here, we just checked it, is 11.2. So that checks. Okay, another one that we had was x minus 3.7 equals 20.4. This one's being subtracted also, but see the equation on this one's on the left, the variable part, instead of on the right like this one. Okay, on the right here, on the left here. Doesn't make any difference. You're still going to move it to this side. So I'm going to add 3.7 to both sides. And notice I lined up the decimals, very important. So I have x is equal to, and I'm going to add these two together. So I have 7 plus 4 is 11. Carry the 1. 3 plus 1 is 4, and bring down my 2. Again, remembering to bring down my decimal straight down into my answer. This is my answer, 24.1, and then I'm going to check it. So write down the original problem. Substitute 24.1 in place of x. And then I'm actually going to check this right here. So I have 24.1 minus 3.7. Okay, I'm just going to bring my decimal down first, which is what I usually do if I'm not trying to go too fast. I can't take 7 from 1, so I need to borrow. That becomes 11. This 4 becomes a 3. 7 from 11 is 4. 3 minus 3 is 0. And then you bring down the 2. So I have 20.4 for this equation. And that's what I need it to be. So that checks. Okay, another one. Okay, we're going back to this type again. So we have 4/3 x equals 36. I am going to, I don't have very much space here, so let me change the page. Okay. So I've, again, 4/3 x equals 36 is the problem that was given. I'm going to rewrite this by moving this variable up here and then putting this over 1. Okay. So 4x over 3 equals 36 over 1. I am going to cross multiply to solve this. Again, I like the variable to be on the left. Bring back down your equal sign. So 4x times 1 is 4x. 3 times 36, I'll do over here on the side for you. 6 times 3 is 18. 3 times 3 is 9 plus 1, which is 108. And again, we went through this in class, but if you haven't done this type of a one-step equation yet, 4 is being multiplied by x. So in order to undo this operation like we did at the beginning of the video, if you had an addition, you have to subtract, or subtract, you have to add. So this is the same type of idea. So if I have a multiplication, I have to divide it. So I have to do the opposite operation. So this is the way that looks. So you put a division line, and I'm dividing by 4 on both sides because that's what's attached to the x. And I need the x to get by itself. Bring down the x, bring down the equal sign, and I need 108 divided by 4, which I'll do right here. Numerator always goes inside, denominator comes out to the front. It's d before n. Okay, 4 doesn't go into 1, but it'll go into 10. Very important you put that 2 right over the 0, okay? Because that shows that 4 goes into 10, not into 1. It should be placed over the 0. So 4 times 2 is 8. And again, that goes in the column of the 0, not under the 1. So 10 minus 8 is 2. Bring down this 8. And then 4 goes into 28 7 times. And it goes in above this 8 because it's going into the 8 that you brought down. So we need to make sure it's in line there. So 4 times 7, 28, no remainder. And we don't have remainders anymore anyways since we're doing algebra stuff, right? So the answer for this one should be 27, okay? And we're gonna check that. So I know there's a lot of work that is involved with these, but it's really important that you're doing them correctly. Okay, I'm gonna have you check it against this, which is just putting the exponent, or excuse me, the variable up in the numerator. So it's basically the same as this problem, and it's just not putting the 36 over 1. So I just simplified one step there for you. But it's going to be 4 times 27 because they're stuck together. You need to multiply them. So substitute, looks like that. And then I'm just going to do it over here. 27 times 4. And check this piece. So 7 times 4 is 28. 2 times 4 is 8. Plus 2 is 10. So this is 108 divided by 3 equals 36. And then we have one more step, which is to take 108 and divide it by 3 this time instead of by 4. And we should get 36. Okay, so let's look. So 3 goes into not 1, but 10, 3 times. Again, goes above the 0. 3 times 3 is 9, which goes below the 0 because I'm looking at 10. 10 minus 9 is 1. Bring down this 8. 3 goes into 18 6 times, which is 18. No remainder. Answer is 36.